Okay, so let's start talking now about how we can convert between Cartesian and polar coordinates. How do we relate them to each other? Um, so here we have our point. Let me even change the color of the point here. Right, we have this purple point here. Right, in Cartesian coordinates, we would say this has coordinates x, y, where it's x distance away here, y distance away from the y or the x-axis. Right? In polar coordinates, we'd say this has coordinates r theta. So how do we relate these? Well, it all comes down to trigonometry here. Right? We have a triangle, we have an angle, we know the length of the hypotenuse, we know the length of these edges, and well, this is a right triangle, so we can make some relationships here. For example, how do we find the length of the base of this triangle? Well, we know that sine theta is sorry, I meant base of the triangle. We know cosine theta is adjacent over hypotenuse. This is going to be x over r, right? Because this base down here, this length is x, right? Same as up there. But what does that mean? This means that x is just r cosine theta. And now we have a relationship that if you give me some polar coordinates, I can give you the x value. Similarly, sine of theta is opposite of our hypotenuse. So that tells us y is r sine theta. Right? So these right here, these are your way to convert from from polar to Cartesian. You actually use these in the Cartesian to polar conversion as well, or you can. Right? But here we are. Okay, so now that we have that, let's do a couple examples here of converting. Right? So example. Here we want to go from polar to Cartesian. So here we're going to do polar to Cartesian. Right? And the first example here we'll look at is, let's say we're given in polar coordinates 1 comma pi over 4. Right? Just to keep it simple to start with. All right. So here, we know this is the r value, this is the theta value, and so we literally just plug them into this formula up here. Right, so x is going to be 1 times cosine of pi over 4. Y is going to be 1 times sine pi over 4. And do the math here, and you'll get 2 over 2 for both. So in Cartesian, this point has coordinates root 2 over 2, comma, root 2 over 2. Right? And if you think about that, polar coordinates is telling us that, all right, we should make an angle of pi over 4 and a length of 1 here. Right? So it makes sense that these two numbers match. And then try and find the lengths of these sides here, and you'll find that they have to be root 2 over 2, or 1 over square root 2. Right, let's look at another example. Right, a little more interesting. 2 comma 3 pi over 2. Actually, this one's also a pretty simple one. Right, so 2 comma 3 pi over 2. Again, this is r, this is theta, so we just pop them in. So x is 2 cosine 3 pi over 2, and y is 2 sine 3 pi over 2. So plug this all in. Here you're going to get This will be 0. This will be... Did I do that right? Yeah, I did that right. This will be -2. Right? So that means in Cartesian coordinates, our point is 0, -2. Now, you can always double check that this makes sense. Right? The way you can sort of plot polar coordinates like this, right? Just sort of imagine you kind of want to draw that polar graph paper on it. So, if, say, this is a circle of radius 1, this is a circle of radius 2, so we're going to be on that second circle there. And our angle, so we're going to be on the second circle, our angle needs to be 3 pi over 2, which is all the way down here. Right, so this is 3 pi over 2. So that means our point is right here. And if we were to describe that in Cartesian coordinates, well, it's on the y-axis and it's below the x-axis, so 0, -2. Right. Here, let's look at one more example. -3, pi over 6. Right? So again, it's just going to be plugging things in here. So x will be -3, cosine of pi over 6. Y will be -3, sine of pi over 6. Let's see, cosine of pi over 6 is √3 over 2, so this is -3 √3. 2. Sine of pi over 6 is a half, so this is -3. So in Cartesian coordinates, we have -3 √3, 2, and -3, 2. Right. So notice, both numbers here are negative, which means we should be in quadrant 3. That fits with this here because the angle pi over 6 is somewhere around here, right? But since we have a -r value, once we go to this angle pi over 6, we then have to move backwards by the distance of 3 to our point. Right, so we stay... Sorry about that. We stay on this line right here, even though this doesn't quite look like it. We stay on the same line as this green dashed one here, but we move the opposite direction. Right? So I think I'll actually split up this video here instead of making a long one. The next video will be converting from Cartesian to polar, because that one's a little more interesting. So, see you in a second.